Good morning, my dear students. Today I am going to take a class on the topic continuity. This is my lecture 2 on this topic. In the last class, I have discussed about the definition of continuity at a particular point. Okay, here I am going to revise few revisions of the particular by showing the graph by graphically. I am going to show that where the function is continuous and where the function is not continuous, what is the condition for continuity of a function at a particular point. In the first graph you see here is very important. The first graph you see, when x is approaches to a is a point on the domain, x-axis representing domain. When x approaches to a from the left, x approaches to a from the left, at that time fx is approaching this point, and in this case, this point, how much distance covered in y-axis? This is L1. That means when x is approaches to a, then fx is approaches to how many distance? L1. X is approaches to a from left implies fx is approaches to L1, and which is called left hand limit. Limit extends to a minus fx is equal to what? L1. Again, x is approaches to a from right. This is the function x is approaches to x is approaches to a, and fx is approaching, and how much distance on y-axis is cover? It is, this is the distance, and it is represented by suppose L2. So that means when x is approaches to a plus, at that time fx is approaches to what? L2, and this is called what? Right hand limit. So from here you see distance L1 and distance L2 are not same. So L1 is not equal to L2, means left hand limit is not equal to right hand limit. And from the graph you see, if you draw the graph, you cannot, that means you have to lift your pen to continue your graph. Okay, so I am drawing the graph in such a way, then drawing in this way, and again lift it and start here. Okay, so it means that the function is discontinuous at that point. That means there is a break at that point. There is a break, and hence the function is discontinuous. And mathematically it is also to say that left hand limit is not equal to right hand limit. That means if left hand limit is not equal to right hand limit, the function is discontinuous at that particular point. Now comes to this. Here in this particular open ball representing what? That at x is equal to a, the function is not defined. Function is not defined means fa is not defined. Fa is not defined. Now you see, when x tends to a from the left, fx is approaches to this, and how much distance ultimately fx is reaching here? This is your fx, all are fx. Fx is reaching here. It means ultimately fx is equal to this distance, means this one on y-axis. Suppose it is L. Similarly, if x is approaches to a, from the right, at that time fx is approaching to what? Again the distance, this one. If you draw on y-axis, then it is called L. That means here we can see that left hand limit equal to right hand limit. X tends to a minus, fx is L. X tends to a plus, fx tends to L. Therefore left hand limit is equal to what? Right hand limit. And since this is the open means what? There is a disconnection. This graph is coming here, there is a disconnection, and again the graph is start. That means at that point the function is discontinuous from the graph. And from mathematically you see left hand limit is not equal to right hand limit still, but the function is discontinuous because the value of the function at the point a is not defined. Now comes to here in this particular graph. In this graph you see fa is defined. It is defined. Okay, fa is defined, and left hand limit is equal to what? If x approaches to a from the left, the left hand limit is L. X approaches to a from the right, fx is also L, and fa is also L. So here the function is you draw the graph, you go and this way, and without lifting you can draw the graph. Therefore the function is continuous at that point. Here you see left hand limit equal to right hand limit equal to value of the function. All are exist. Left hand limit exists, right hand limit exists, fa is also exist, and this is the definition of continuity of a function at a particular point, which is written as limit x tends to a minus fx equal to limit x tends to a plus fx equal to fa, provided all are exist. In the last class I have done a mistake here. I have written a minus, it should be a plus. Okay, you rectify your definition. So this is the definition of continuity of a function at a particular point, and when this exists and this exists, both are equal, we can write limit exists, original limit exists, and which is equal to what? F. This is also an alternative definition of continuity of a function. This definition is used to find the continuity of a function at a general point or arbitrary point in the domain, and this is the definition I am going to use, or we are going to use in a particular point to check the continuity of a function at a particular point. For particular point you use this, for general point you use this. So just I revise this concept again, and now I am going to solve few problems regarding your this particular concept. Then you can get an idea how to solve a function to be continuous at a particular point. Here the problem is, question is, check the continuity of a function fx is equal to modulus of x at x is equal to 0. Okay, so you know modulus function, modulus of x is equal to what? X when x greater than equal than 0, and minus x when x less than 0. You can write x less than equal than 0, and here x greater than 0, no issue. When x equal to 0, modulus of fx means modulus of x is equal to 0. When x greater than 0, modulus of x is equal to x. When x less than 0, modulus of x is equal to minus x. Then you see your left hand limit, limit x tends to 0 minus fx. X tends to 0 minus means what? We already know that x tends to 0 means x is approaches to 0 from left, that means x is less than 0. X is less than 0, and when x is less than 0, the functional value, what is fx? Fx is equal to what? Minus x. It can be written as h tends to 0 minus h plus h. Why? You see, x tends to 0 minus means what? X less than 0. That means what? You can write x is equal to x 0 से छोटा है, so 0 से एक पॉजिटिव नंबर माइनस करना पड़ेगा, where h is a very small quantity, whatever you imagine. So x is equal to, why I am taking this, I am already given a explanation about in the last class in the limit. So when x is less than a, then x can be written as a minus h. Here x is less than 0, so we can write x is equal to 0 minus. Now x is tending to 0, x जब 0 हो जाएगा तो h क्या होगा? Also 0. So here I am writing x tends to 0. Here 0 minus means x is approaches to 0, from left. Just x tends to 0 here. X tends to 0 means h tends to 0. Okay, and x is replaced by minus h, so minus a plus. So limiting value is 0. So left hand limit is 0. 0 is a finite and fixed quantity, therefore left hand limit exists. Now right hand limit, limit x tends to 0 plus fx. When x tends to 0 plus means x is greater than 0. When x is greater than 0, fx is equal to what? X. So you can write here x. and finally you write limit h tends to 0, that is x is replaced by what? h. How? X greater than 0 means what? X 0 से थोड़ा बड़ा है तो 0 plus some positive number. So x tends to 0, x tends to 0 implies h tends to 0. 0 plus is not a number, number is 0. Okay, number is 0. x जब 0 हो जाएगा तो h tends to 0 हो जाएगा. ठीक है, ultimately result is 0. So left hand limit is equal to what? Right hand. Also, what is f0? When x equal to 0, f0 equal to what? You put 0, then you will get 0. So finally, left hand limit is equal to right hand limit is equal to f0. All are same. So LHL, right hand limit is equal to what? f0. Therefore, f is continuous at x equal to 0. Okay. Finally, what we get? F is continuous at left hand limit is equal to right hand limit is equal to what? f0, and therefore f is continuous at x is equal to 0. In this way, we can check the continuity of a function at a particular point. Okay. Now, I am going to discuss another point, another problem on continuity. So, question is what? Fx is equal to x square plus 3 when x not equal to 0, 1. Your point is at x is equal to 0. At x is equal to 0, whether you check whether the function is continuous or not. What will be your left hand limit? Limit x tends to 0 minus x not equal to 0 means x less than 0 and x greater than 0, both are included in this particular condition. So x tends to 0 minus means x is less than 0. Okay, and x is less than 0 means x not equal to 0. So your function value will be what? What is function? Function की जगह में आप क्या लिख सकते हो? fx is equal to what? X square plus 3, and as x tends to 0 minus, so x less than 0, so you can write x is equal to 0 minus h. x tends to 0 implies h tends to 0 होगा. जब x को h में कन्वर्ट करेंगे तो लिमिट भी चेंज करना होगा, तो यहाँ और इधर लिमिट क्या होगा? लिमिट h टेंस टू 0 हो जाएगा. एक्स स्क्वायर प्लस 3 क्या होगा? माइनस h होल स्क्वायर. x की जगह में माइनस h होगा तो h स्क्वायर हो जाएगा. तो फाइनली लिमिटिंग वैल्यू इज 0. राइट हैंड लिमिट विल बी सिमिलरली limit x tends to 0 plus means x is greater than 0. X is greater than 0 means x not equal to 0. That means again the function is what? X square plus 3, and here you write limit h tends to 0. Since x tends to 0 plus means x is greater than 0, so you can write x is equal to 0 plus something positive. X tends to 0 implies h tends to what? 0. Okay, so finally you write here x is replaced by what? H. So h square plus 3, and which is equal to what? Sorry, here it is equal to what? 3. It is equal to what? 3. Also you check what is your f0. When x is equal to 0, go to the function. So when x is equal to 0, f0 equal to what? 1. So you can write f0 is equal to what? 1. Here the left hand limit is not out is equal to right hand limit but not equal to f0. So it is not satisfy the condition of continuity at a point. Therefore left hand limit is equal to right hand limit but not equal to of f0. Therefore f is not continuous at x is equal to 0. Okay, so in this way we can check the continuity of a function in some particular points. And very important thing is that how you convert x in terms of h. When x tends to 0, when x tends to a minus, when x is approaches to a from left, you always write x is equal to a minus h. What is h? H is a very small quantity which is positive, and when x is approaches to a from right, you can express as x is equal to a plus h, where h is positive. Okay, this thing you remember, then it will be easy for you to solve the problem. Okay, so I hope you understand these two particular problem and whatever with the basic concept I have discussed. So thank you very much to listening my lecture. In the next video I am coming with a new topic, and where I am going to discuss the continuity of a function, such type of function like constant function, that is a identity function, and then polynomial function. All such type of function I am going to discuss. That means I am not going to discuss continuity of a function at a particular point. I will discuss the continuity of a function throughout its domain, whether the function is continuous in the whole domain or it is discontinuous some part of the domain, that I am going to discuss. Okay, so thank you very much. Thank you.